Hello, everybody. We'll continue our chapter 2 in digital electronics. Fast review, AND gate. We have two input AND gate. AND gate, this is the symbol of AND gate. This is the expression, mathematical expression. Okay, F output equal A times B or AB. This is the truth table. 0 means low voltage, 1 means high voltage. 0 means off, 1 means on. So we have on off of the input A and B. 0 0 means 0 volt, 0 volt. Low voltage, low voltage. Off, off. Okay, the output will be off or 0. 0 1 or 1 0. 0 1 or 1 0. 1 means high voltage, high voltage. 1 means on, the transistor is on. 1 means 5 volt. Okay, so 1 will be on, high voltage, 5 volt. 0 will be off, low voltage, 0 volt. Okay, and 1 high voltage on, not necessary to be 5 volt. It can be 3.3 volt, 2.5 volt, or even in the latest technology will be 0.6 volt. So 1 will be 0.6 volt in later transistors, or 1 volt or 0.9 volt in newest transistors. But today or before midterm, the older transistor, BJT transistor and MOSFET, we will consider it as 5 volt. And in your lab, you will be input 5 volt. Okay. Later in our simulation, in using multi-sim or microcap simulator, circuit simulator, we'll use other than 5 volts. Later we'll see it. Now, the AND gate will be 1, the output will be true or 1 only one time when A and B are true. So 1 is true, 0 is false. True, true, give us true. High, high, give us high. Okay, else the output will be off, 0, false. Or is opposite, similar to opposite. So or the output will be A plus B. This is the symbol. Okay, arc, we put here arc. A plus B is similar to addition. This and similar to multiplication. Okay, similar, it's not exactly similar. Here the plus similar to addition. So the only case the output will be off or false or low voltage only in one case. 0 0 will give us 0, else always or give us true 1. Okay, not for one input, the opposite of the input. The output will be opposite of the input, not its inverter. Inverter means opposite. Okay, A bar or A prime. So if input is 0, output 1. If input 1, output 0. Now we have NAND and NOR. NAND, it's AND plus inverter. We put here bubble. Bubble means inverter. This bubble means inverter. So NAND, it's not AND. The AND is from not. Not AND mean NAND. So NAND, it's AND plus inverter. As we can put AND then inverter, the same. When you put AND and the inverter, so the output will be inverted. So the output will be 1 1 1 0, the opposite of AND. NOR, the same. It's OR plus inverter. We put bubble here. NOR, this is the output of OR. We inverted. Put opposite. 0 becomes 1 and 1s becomes 0. Okay, this is the basics logic gates as a review. Basics logic gates, we will do it in your lab. Now BJT. Now continue with BJT, bipolar junction transistor, will begin by inverter. So not gate or inverter, one input, one output, 0 becomes 1, 1 becomes 0. Or we can use the NAND or NOR, we can use NAND or NOR and transfer the NAND or NOR as inverter, similar to these diagrams. If we put on NAND two input as the same input, give us inverter. The same for NOR. The same for NOR. The two input combined together give us inverter. Or if I put one of the input in NAND, if I put one of the input at high, plus V means high, and the input here, the output will be inverted. Reverse in NOR, one of the input will put it on the ground, 0 volt, on the ground, 0 volt. Okay, the output will be inverted. Okay, so this is as refresh. Now go to the inverter transistor level. Here in BJT, we cannot put the input directly to the base or directly to the collector, CBE. We cannot put 5 volt directly to the transistor. The transistor will burn out. الترانزستور بيحترق اذا حطينا دغري ال 5 فولت عليه. Okay, that's why we must put resistor. Okay, resistors on C, on B, later on E. Okay, but on one of them we can put ground. Ground ما بيحرق, don't affect anything on the transistor. But if we put here 5 volt or here 5 volt directly, the transistor will burn out. So we put resistor. This resistor called for the side of collector C. This side is C, collector RC. This is B, base RB, and this E. Okay, so we put two resistors, RC and RB. Now, this is the truth table of this inverter. This is inverter. The first circuit is one transistor, two resistor in BJT inverter. So when the voltage N here is low, the transistor is cut off, then the transistor is off, then the output from C will be directly connected to VCC equal 5 volt. Whereas when the input is high, okay, give us the saturation mode. The transistor will be in saturation mode, and they connect C on E. So now we have the output is connected here. Okay, but here we have always VCE in BJT transistor. Always we have in saturation mode. Always we have V voltage on CE. When it's on VCE, always 0.2 volt. So here we don't have zero output. Okay, we have low output. Yes, it's low output, high input, low output. But this low output is not 0 volt. It's 0.2 volt. Okay, we call it V output low, 0.2 volt. We call it V output low, and the 5 volt here, V output high. So V output high equal 5 volt, V output low equal 0.2 volt. Now about the input. When we have here the input between two values, 0 volt and V input low, VIL, V input low, which is in BJT equal 0.7 volt, in BJT equal 0.7 volt. So if the V input at this range, this is low voltage. In BJT, we call it low voltage, low input voltage, from 0 to 0.69. Okay, so the transistor will be off. After 0.7 and the input high, between this region, between the input low 0.7 and some value here around 1.6 volt or 2 volt, less than 2 volt, the transistor will act as active mode, which is the output will be linear or amplifier. Okay, this is for communication engineer, for antenna mode operation, for antenna application. Okay, we don't care about it. When we have high voltage, which is the voltage input is between the input high and 5 volt, called high voltage, this is saturation mode, and the output will be low, 0.2 volt. Now we have output high 5 volt, the output low 0.2 volt, the input low is for BJT is fixed to 0.7 volt. But now the question is, what is the value of the input high? So the input high will be dependent on RC, RB, and beta of the transistor. So the input high will be depend on 3 variables. Now, to calculate the input high, so as you can see, if I want to calculate the input high, the input high will be common intersection between active layer and saturation mode, in active mode and saturation mode. So the input high will be equal here and here at the same time. So we can use these equations for saturation mode and the equation for active mode like this. In saturation mode, the output equals 0.2 volt. So the voltage in VRC here, VCC, equal 5 volt, equal voltage on RC, which is equal RC times IC, voltage equal RC, RI. As you can know, it's basic equation, voltage equal RI. So voltage on this RC equal the value of RC times IC, okay, equal VCC minus VCE saturation mode, equal 4.8 volt always. In BJT, always we have here, the voltage here is 4.8 volt. Depend on the value of R, give us another value of IC. So IC equal 4.8 over RC. So if RC is big, IC becomes low, okay? And inverse. This is first equation from saturation mode. Now we'll go to active mode. In active mode, we have equation about IC equal beta IB. This is the active mode. IC equal beta IB. Then here IB equal IC over beta. Okay. We put the value of IC here. We have 4.8 over beta RC. So IB equal this. Now I want to calculate voltage RB. V input high equal V RB plus VBE in saturation mode. VBE in saturation mode always equal 0.8. VCE in saturation mode always equal 0.2. VBE in saturation mode always equal 0.8. Okay, so in saturation mode we have voltage BE equal 0.8 plus voltage on RB. So voltage on RB equal IB times RB, RI. So RB times IB. We replace IB by these values here. So the input high equal VBE plus VRB. The input high will be equal this voltage plus internal voltage here. We have here internal voltage 0.8 volt plus this voltage RB. So equal 0.8 plus this equation times RB. This is how to calculate the input high. Okay. Now, example. Determine the high and low noise margins for the same inverter. Given that VCC equal 5 volt, resistor on B equal 10 kilo ohm, resistor on C equal 1 kilo ohm, and beta for this transistor equal 60. So we have these values already. We have these values which are constant values for BJT. The V input high, we use this equation. The calculation give us the voltage input high equal 1.6 volt. So Any voltage input below 1.6 volt, the transistor will be off. Okay, will be off. So the output equal 5 volt. Okay, this is voltage input high. هلا sorry, any voltage input below 0.7, the transistor will be off and the output will be 5. The voltage between 0.7 and 0.6, this is linear mode, works as antenna. We don't care about this mode. Voltage input above 1.6 volt, bigger than 1.6 volt to 5 volt means high input, give us here low input 0.2 volt. So we will draw these values to get this. This is called voltage transfer characteristic. The input as x axis, the output as y axis. Here the input variation and here the output variation. Okay, this is called voltage transfer characteristic for the inverter, BJT inverter. Now, after calculating all these values, we want to draw them. Now, from 0 input, from 0 to 0.7, the output will be high. So the transistor mode will be cut off and the output will be exactly 5 volt. Exactly 5 volt. Between 0.7 and 1.6, the input high here, okay, the input low, 1.6 is equal V input high. Between the input low and the input high, the transistor in active mode will be linear. Okay, then at saturation mode, when the input above 1.6 and till 5 volt, the output will be low. This low equal VCE equal 0.2 volt. So we draw it as parallel here. So we have 5 volt linear mode between this point 0.75 to 1.6 0.2. This is active layer, sorry, active mode, antenna application here. Okay, then constant as low 0.2 volt in saturation mode. So in transistor we have 3 modes: cut-off mode, active mode, saturation mode. In inverter, and a cut-off will be high voltage 5 volt, the output high 5 volt. In saturation will be voltage low, the output low equal 0.2 volt, and the input is in between the input low and the output high. The mode is called active mode or linear mode. This is not, we don't care about this layer, this mode, because this mode is for electronic engineer and communication engineer, and used only for analog circuit, used on antenna applications and analog circuits, not on digital. In digital circuit, we don't use active layer. Okay, only we use cut off, saturation, on off, on off, off on. Okay, off transistor, only transistor. In between, you don't care. Okay, this is called voltage transfer characteristic. Any question for this drawing? Good. Good. Now, the noise margin. What are the noise margin? The noise margin is the boundaries or the range between the input high, input low, output high, output low. So here we have from 0 to output low 0.2 volt. Okay, noise margin low, the noise margin low equal the input low 0.7 minus the output low 0.2 volt, the red region here. The noise NML, noise margin low, equal the input low minus the output low, equal 0.5 volt. Okay, here in this region we have noise margin. Now, between 0.7 and 1.6 is active layer, is active mode, linear mode. We don't have here noise margin. But between 1.6 volt till 5 volt, we have noise margin high, NMH, noise margin high equal V output high 5 volt minus 1.6 V input high equal 3.4 volt. Okay. So in BJT inverter, the NMH noise margin high equal to 3.4 volts, which is big. Okay. In low margin, noise margin low equal 0.5 volt. It's small. Here we have small value. Here we have big value. Okay. The noise margin, we use the noise margin to characteristic the circuit. If the noise margin is high, okay, so the circuit is good or bad? Who said? If we have noise margin high or low, which is the better?
Low.
Low.
High.
Okay, high, low, low, high. Depend on the application. Depend on the application. If it's analog application, antenna and communication engineer, they focus on high margin noise margin, because they focus on low margin. They need more active mode. Here we have active mode small. If we decrease the noise margin high and decrease the noise margin low, so the active mode here, the voltage between input low or input high will be big, so it will be more attractive to electronic engineers or communication engineer about analog circuit or about antenna application. But in our digital circuit, we need low margin noise. Noise margin will be low. So we want our circuit to be low noise margin, not high. Okay? Sorry. High. Sorry. In digital electronics, we prefer high noise margin to eliminate this region. That's why we want to make higher NMH and higher NML to eliminate this, to cut off from linear or active mode, to minimize input low, the difference between input high and input low. كل ما صغرنا هيدي الريجن كل ما بعدنا نحن من الاكتيف مود اللينير مود، لانه هيدي بتضرنا نحن بالديجيتال سيركت، بتضرنا، تعملنا نويز، تعملنا اوتبوت ما بدنا اياه، تعمل امبليفاير لانه اوكي بيطلع نويز كثير، بتشوفوها بكره بالسيموليشن. فنحن بهمنا بالديجيتال الكترونكس، in digital electronics we focus to remove this region. To remove this region, we want NML to be big, NMH to be big also. High number, to eliminate this. Okay? Now, any question for this? Perfect. Now, what is the classification of the transistor? Every new transistor type is created to operate properly in a specific set of applications. What are the applications? These applications define the general properties and parameter of the transistor. So I want antenna application, so we go to some models of transistor that give us high mode, linear mode. Noise margin will be low. If I want our application to be on digital circuit, the inverse. We want to choose a transistor that has higher noise margin and lower the active mode. Okay? So we have now the category in kind of transistor. We have small signal transistor, this kind ECB. you will buy them in lab I think اوكي هتستعملوا باللاب. ECB اوكي emitter collector base. These are designed to amplify. هيدا small signal transistor بيستعمل الامبليفاير to amplify the amplitude of the single input signal with reduced overall power consumption. These operate at low voltage and low current. These transistors are characteristic by small size and are free air cooled, do not need heat sink to keep their working temperature below destructive temperature level. يعني في بعض الترانزستورات بيحموا كتير بنضطر نحط لهم ألمنيوم وفان، ألمنيوم وفان لنعمله cool down. This small signal transistor similar to this, no need to put heat sink. Heat sink هي الألمنيوم اللي تبرد to cool down the temperature وفان no need. هي small signature small signal transistor used to amplifier. Now we have power transistor. Power transistor بيشتغل بالقلب. They are designed to control relatively large current. Large current. We need here large current. It's not usable in digital electronics. And large current can reach tens of amperes and handle high power dissipation. High current, high power. Small signal transistor, low current, low voltage, low power. Low current, low voltage, low power. هون حيصير high voltage. Sorry. بالpower transistor. High power, high voltage, high current. They are cooled by heat sink. هون اجباري نحط heat sink. اوكي نحط الهيت سينك والمروحه. مثل اكثر شيء بيستعملوا باور ترانزستور مثل example audio power transistor used to drive loud speakers are example for this category. تعليق الصوت بالتلفزيون او بالراديو بسجل السياره او كذا audio power اوكي او الامبليفاير لما نجيبوا امبليفاير وتعلي الصوت بالحفلات على سبيكرات عاليه هذا الامبليفاير بيستعمل باور ترانزستور اوكي بيضرب السيجنال ب 400 و500 مره اوكي بيضرب الانبوت سيجنال بيضربها ب 500 مره بيعمل امبليفاير 400 ل 500 مره اوكي فبيستعمل الباور ترانزستور بحجمه كبير هذا حجمه بنحط له الومنيوم هيت سينك الومنيوم هيت سينك اوكي اكزامبل هذا هو تغيير كونفيجريشن BCE اوكي وبعض الاحيان بحط له مروح يا بكبروا الالومنيوم وبعض الاحيان مثل سي بي يو بقلب الكمبيوتر السي بي يو بقلب الكمبيوتر لانه بيحمى كثير بحط له هيت سينك وبحطوا مروحه عليه مشان يبورده وينزل. هيدا الاكزامبل هيدا ترانزستور TIP 35C بيوصل ل 25 امبير اوكي بيوصل ل 25 امبير بيضوبات فيه. هلا عندنا كمان للكهرباء للباور هو للباور للكهرباء مش للكوميونيكيشن هاي فولتج ترانزستور. They are designed to operate high voltage اكثر من 1500 فولت على العمود الكهرباء بيكونوا هول اللي بحطوهم على عمود الكهرباء اوكي. These transistors are used to operate as electronic switches. Transistors used to drive high voltage flyback transformer and TV sets are example of this category. حتى بالتلفزيون للصوره القديمه عم نحكي CRT TV مش LED مش LCD او LED TV. An old version of TV CRT TV بسموها cathode ray tube TV يلي كبير القديم بقلبه هيدا النوع الترانزستور اوكي بيوصل 10000 CRT TV بالتي في العادي بيوصل ل 10000 فولت. عندنا كمان نوع frequency of operation. Transistor used for high frequency applications have special internal design to respond rapidly to change of input signal voltage. اوكي هذا frequency operation بيستعمل تنشوف الاوبريشن دغري اقروها باكج اون فاكتشر اللاين باكج ار يوزد فور ذيس سبيشال ترانسميشن كمان بيستعملوهم بالباورز باللاينز بالفولتج العاليه من عمود لعمود اوكي وهذا شكله اوكي حنوقف اليوم ليتر حنكفي دايود ريزيستور لوجيك جيتس حناخذ دايود مع ريزيستور اوكي so we stop here today. Any question؟
لا دكتور